Let's talk about measuring images, goodness with images. We're going to look at pixel-based false positives and false negatives and stuff, and and something called IOU. So I've got a spreadsheet for it here, and I'll put the link in the description. So suppose we had this 10 by 10 image here, and it's a segmentation, and B or blue is the ground truth region that we're interested in. It's a 4 by 4 patch in the middle of the image, but the details aren't super important. It could be an animal's face or a hole in a piece of steel, for example. We'll just call it a blob for now. Suppose our AI had given us this prediction, which is a segmentation. We'll use yellow or Y to show it. It's another 4 by 4 square, but shifted up and to the left by 1 pixel from the true blue square here. Let's overlay them, combining colors that overlap. Yellow and blue makes green, so I've labeled that G. Um, so let's start by putting a box around the original true blob. Think about where that should go. I'm going to highlight it here. So it's this original 4 by 4 box. And we're going to do that border there. So that's our original true blob. Based on that, which pixels are true positives, where the algorithm said that the pixel is part of the true blob, and it is actually part of the true blob? Which pixels are true negatives, which are false positives, which are false negatives, etc. Pause to think about it. So I've got it labeled here. So the overlap is the true positives. The things that was originally part of the true blob, but the AI didn't detect, that's a false negative. It said it's negative, but it's false. The things that the AI said are part of the image, part of the blob, but weren't part of the original blob, those are false positives. And then everything else out there is a true negative. Over on the side here in column M, I'm an N. I'm putting in a way to count the false positives and the true positives, etc. You don't have to know the spreadsheet formula here, but it is a kind of nice Excel or spreadsheet trick to know how to do that. I'm not going to ask you to do that for this class, although it might come in handy on a project. And then how would we compute the accuracy? We'd usually say, well, how many predictions were accurate divided by how many total predictions did we make? So we did 10 by 10 matrix of predictions. So we had 100 pixels. So we could say our accuracy is the number of true positives plus the number of true negatives divided by however many pixels there were, 100 pixels. As the thing is, this would get larger if we had a larger image with more non-blob pixels around, because we'd have more true negatives, as long as the prediction didn't change. It would be nice to have a way to summarize the results that avoids that issue. So we're going to introduce an idea that we want to maybe only consider just the local region near the blob, not the whole image. How local do we want to get? We could think about just those pixels involved in either the true region or the predicted region, or both. That would be the union of those two regions, as the things in this or that or both. We would hope that the intersection of the regions, that is, the things that were in both true and predicted, would be the same as the union. That is, we would want no pixels in the true blob or in the prediction that were outside the intersection. The union is all the false positives, true positives, and false negative blobs of pixels. The intersection is all the true positive pixels. And then we could say, well, we got, let's say, 9 in the intersection. How many in the union here? It was all the true positives, false positives, and false negatives. So we could say how many pixels were in the intersection, total of 9. How many pixels were in the union, total of 23. And then do intersection over union, or IOU, which is the intersection count divided by the union count. When we do that division, we get 0.39 or 39%. What IOU would you expect for perfect overlap? Take a sec to think about that. What IOU would you expect for no overlap at all? Take a sec to think about that. I would say for perfect overlap, the intersection and the union are equal. So we get I over U, one thing divided by itself would be 1.0 or 100%. What would you expect for no no overlap at all? We'd have intersection equals 0. So I over U would be 0 over whatever the union is, or 0 or 0%. So IOU should be between 0% and 100%, and we want it to be near 100%. Let's take a look at another little pretend image I've come up with. So this is scenario 2A, and we're gonna compare it to scenario 2B in just a minute. So here we have the 10 by 10 image again, and I've got these 3 pixels are false positives, these 9 pixels are true positives, and these 3 pixels are false negatives. And I've got the counts over here. Um, uh, so the intersection count is 9, the union count is 15. Oh, before we do that, let's put a box around the original true blob. Think about where that should go. That would be the true positives and the false negatives, the things that the algorithm didn't detect but should have detected. So our box around the original blob would be that 4 by 3 thing. So this gives us an accuracy of 94% and an IOU of 0.6 or 60%. So that's scenario A. Let's go to scenario B. Again, 10 by 10 thing. Let's think about where to put a box around the original true blob. So in this case, it's all the true positives and all the false negatives, but now there are twice as many of them, and there are also twice as many false positives. So our accuracy is now 88%. So that's interesting. The accuracy changed in between, the accuracy percent that we compute changed in between these two. But do they feel like maybe they're kind of the same accuracy? I don't know. And then I've got the IOU computations over here. I've got them in white text on a white background, just temporarily. I suggest you pause the video and go ahead and compute the IOU for yourself, or at least imagine what it should be. Let's go highlight those computations and show them again. So we now have an intersection count of 18 and a union count of 30. And so the I over U is again 0.6 or 60%. What do you notice about the results? We got the same IOU for scenario 2A and 2B. What do you wonder about that? Take a minute to wonder. We might wonder, is this result, 2A and 2B, is that just a coincidence? Or can we say it will always happen in some kind of set of scenarios? Can we say that like doubling or tripling the pixel counts doesn't change the fraction result for the IOU? We notice the accuracy changed from one to the other. Think about why that happened and whether you think accuracy is a good way of measuring things in this kind of situation. I have another pair of scenarios here. So scenario 3A and scenario 3B. And these are part of the homework, actually. So it's got the counts done over here for you for 3A and 3B. Part of the homework will be for you to compute the intersection and union counts and then compute the I over U. And then compare that from 3B, compare that to 3A. And some wrap-up questions that are part of the homework. What do you notice? What do you wonder? Is the result just a coincidence, or can we say it will always happen when something is true about the image? I want you to give an image segmentation context example of when false positives are much worse than false negatives. For example, like when outlining tumors in MRIs or when spotting cracks in steel. I'm not saying that's the right answer, but that's like when I say an image context example, that's what I mean. Then explain why false positives are much worse than false negatives in whatever situation you gave, and then do the opposite. And then I've got some optional questions down here. All right.